Uh, Good evening, friends. Welcome back. Welcome to Ekeeda. And in the present video, we will solve some of the questions on the settlement. So let us start with settlement analysis. Settlement analysis. Yeah, hi Lokesh. And so in this present chapter, we will discuss about the uh, immediate settlement, and also we will discuss about the consolidation settlement, or we will call it for the primary settlement. And mainly we will study about settlement for the cohesive soils. That means if you are applying loading immediately on the soil, so immediately how much settlement will happen in the soil. And after some time, after placing of some load, if you are leaving it for say 6 years or 10 years like that, if you are taking some time, then what is the settlements happening in the soil? Okay, now, so first for the corrosive soils, let us talk about Lokesh. We are discussing about the consolidation chapter, and the consolidation we are discussing the how to find the settlement if there is a consolidation happening in the soil. Okay, so let us talk about for the immediate settlement. Immediate settlement. So immediate settlement is simply calculated by using. So this we are discussing for the cohesive soils. So immediate settlements in cohesive soils can be found out by using the relation Q into B into 1 minus mu square divided by E into I. So here Q is nothing but a pressure at the bottom of the foundation. So Q is nothing but a pressure at the bottom of the foundation, and B is nothing but a width of the foundation, or we can also call it as a width of the footing. Or suppose if you are talking about the rectangular footing, so we'll have the two dimensions L and B. So out of those two dimensions, we have to take the smaller magnitude, and mu represents the Poisson's ratio, and I represents the influence factor. It's depending upon the shear. Suppose if you are talking about the rectangular foundation, this influence factor will be depending upon the ratio of L by B, and E is nothing but a Young's modulus of the soil. So by using this relation, we will calculate the immediate settlements. That means if we are applying load on the corrosive soils, immediately after the application of the loading, how much settlement will happen in the soil? Okay, let us see some of the problem. Suppose, let us say that there is a foundation which is having a dimensions of 2 meter by 3 meter, and the load acting on the foundation, let us say the load acting on the foundation P, that is equal to 750 kilonewtons. Okay, sorry, let us make it as a 650 kilonewtons. And let us assume that the parameters, that is nothing but a Poisson's ratio, is given as 0.37, and Young's modulus of the soil is given as let us say 9.8 megapascal, and influence factor for the foundation is given as 0.7. So if you're applying a load of 650 kilonewtons, immediately how much settlement will happen in the corrosive soil? So just directly apply it on the formula. That is nothing but a immediate settlement. If you recall the formula, that is Q. Q is nothing but a pressure at the bottom of the foundation. But here did they given any pressure? No. They have given us the total force acting on the foundation. So total force acting on the foundation is given, and area of the foundation is given. So if you know these two, so first we have to find out what is the pressure that is acting at the bottom of the foundation. That will be equal to, how can you find out this pressure? That is nothing but a force divided by area. So what is area here? As it is a rectangular foundation, force is given as 650 kilonewtons, and divided by cross area is nothing but a 2 meter by 3 meter. So if you are solving this, 650 divided by 2 into 3, 6. So if you are solving this, we are getting it as around 108.4 kilonewton per meter square. That's it. Substitute in the given equation. So immediate settlement Q is nothing but a, so let me write it on the left side so that I can completely write. So immediate settlement, that will be equal to 108.4 times whatever the width of the foundation. Out of these two, remember, always we have to take the smaller dimension. So okay, while reading the formula, you can say okay, B is nothing but a width of the foundation. But while in the examination hall, again you may get doubt, either I should take 2 meter or 3 meter. So always you have to take the smaller dimension, that is nothing but a 2 meter. So here I'm substituting every unit in terms of the kilonewtons, and also I'm substituting in terms of the meters. Okay. So into 1 minus mu square. So 1 minus Poisson's ratio is given as 0.37 square into influence factor is given as 0.7 divided by Young's modulus of the soil. So let us just convert this into 9.8 megapascal into kilonewton per meter square. So how much you will get it? So 1 megapascal is nothing but a newtons per mm square. So or else we can convert, instead of converting this into kilonewton per meter square. So here I can convert 108.4 kilonewton per meter square. If I convert into mm, how much I will get? 108. So convert kilonewton into newtons. That means we have to multiply by 1000. 108.4 into 10 cube newtons. Convert 1 meter into mm, 1000 mm. Like that we are having meter square. That means 10 to the power of 6 mm square. So if I substitute it here, 10 power 3 and 10 power 3. So here 10 power minus 3 will come. Here it is 2 meter. If I convert into mm, so again I have to multiply by the 10 cube. Then I can directly take E value in Newton per mm square. That is directly 9.8. So if I solve this, then we will get immediate settlement is occur to be around 13.44 mm. So it is just a direct formula based question. And here we have to remember that B is nothing but a width of the footing or foundation, and that we always have to take the smaller dimension. If it is a square foundation, then no problem at all. But if it is a rectangular, then we have to take the always smaller dimension. Okay. Now let us discuss about the primary settlement. Let us discuss about the primary settlement. So primary settlement, and also we will have the secondary settlement. Secondary settlement. So as you are applying loading under long-term conditions, then if it is a corrosive soil, then because of the loading, the water may escape from the clay or corrosive soil. So as the water is expelling from the soils, then settlements can occur. So because of the expulsion of the water, if there is a settlement happening in the soil, then that we will call it as a primary settlement. Or simply we can assume that as you are applying the loading on the long-term conditions, if there is any like very permeable soil surrounded by the corrosive soil, then whatever the water content present in the clay soil, that may expel that way through the permeable soils. So in that case, the thickness of the soil may decrease. So that is what called the primary settlement. And also we can call it as a consolidation settlement. Consolidation settlement. And after expulsion of water from the corrosive soil, still if we are applying the loading, then there is a probability that, not probability, if your loading is very long term, then the sizes of the soil particles may also changes. So because of the decrease in the sizes of the soil particles, if there is any changes in the thickness, then that comes under the secondary settlement. Okay, so in this consolidation, mostly we will concentrate on the primary settlements, or we will also call it as a consolidation settlement. So in the exams, then they can ask different data, and we have to find out what is our primary settlement. So depending upon the given data, then we should be able to, or we have to find out the settlements. So like that, they may give the different properties or different conditions what they have observed in the site, and then depending on that, we should be able to find out. Suppose, let us say in the case one, or let us assume that initial void ratio is given. Let us say that initial void ratio is E naught, and because of the pressure acting on the soil, let us assume that the void ratio has changed. Why? Because as the water is expelling from the soil, so void ratio may change. So because of the application of the some external pressure, let us assume that the void ratio has changed to E1. So we don't know what is the pressure that is applying on the soil. Only we know that initially the void ratio is E naught. After the application of some pressure, then the void ratio at present is E1. So because of the application of pressure, we can find out the change in void ratio. Change in void ratio is nothing but we can represent E1 minus E naught. Or as E naught is larger in magnitude, then we can say it as a E naught minus E1. So if you know the void ratios, and if you know the initial thickness, let us say H naught is the initial thickness of the soil. So if H naught is the initial thickness, and if we know the initial void ratio, and also if we know the change in void ratio, then we can find out the settlement by using the relation, that is delta H divided by H, that will be is equal to delta E divided by 1 plus E naught. So if we directly know the initial void ratio and change in void ratio, and if we know the initial thickness of the soil, then by using this relation, simply we can find out. That is, suppose let us assume that you are having some corrosive soil, and let us assume that your corrosive soil thickness is, let us assume that it is 2 meters. And initially, without any application of the pressure, let us assume that your initial void ratio is 0.98. After the application of some pressure, let us assume that we are applying some pressure on the soil. Let us say the magnitude is Q. That means we are increasing the pressure. Because of the increase in pressure, after some time, if you are checking, then you found out that your void ratio is obtained to be 0.97. So then what will be the settlement happening in the soil? So here we don't know what is the pressure applied, but we know the void ratios after the application of the pressure. And also we know the initial thickness. That's it. Substitute in this equation. Let us assume delta H is the change in thickness, or we can simply call it as a settlement, divided by what is initial thickness, 2 meters. That will be equal to change in void ratio. What is the change in void ratio? Initially 0.98, after that it is 0.97. Then what is the change in void ratio? That is obtained to be initial, that is 0.98, minus what is the final, 0.97. So then we are getting it as a 0.01. So this is what the change in void ratio. Then substitute here, 0.01 divided by 1 plus what is initial void ratio, 0.98. So delta H. So 1 plus 0.98. So 1.9. Simply if I consider it as a 2. So just for the rough calculation part. So what I'll get, 0.01 into 2 divided by 2. So 2 gets cancelled, then I'll get 0.01 meters as I'm taking thickness of the soil in terms of the meter. So if I want to convert this into mm, then multiply by the 1000. If you multiply by the 1000, then how much will get? 1, 2, 3. That means 10 mm is the settlement happening in the soil because of the applied pressure Q. So this is what simple direct question if we know the change in void ratio. Okay. Now let us assume that, let us say in some other case, we know that the coefficient of consolidation. What is the coefficient of consolidation? Let us say if we know the AV. So how can you represent it? This we can represent it as a change in void ratio to the change in stress. So somehow, if we know the coefficient of consolidation, then how can we find out the settlement happening in the soil? So let us recall the previous equation. What is the previous equation we have recalled? That is nothing but a delta H. Also, you can write it down, or else you can write it down the settlement. No problem. So delta H divided by H naught, that will be equal to delta H divided by 1 plus E naught. Sorry, delta E. So in addition to the coefficient of consolidation here, we also know what is the increased in the effective stress. So we also know the this much magnitude, and we also know this much. Then if we know the increase in effective stress, and also if we know the coefficient of consolidation, from this you can find out what is your change in void ratio, that I can write it down as a AV into delta sigma bar. That's it. Substitute in the given equation. Then how much we'll get? I can find out change in thickness, or I can also call it as a settlement, primary settlement. So I'm repeating as subscript P, that will be equal to, if I retake H naught to the right side, then what I can write? Delta E divided by 1 plus E naught into initial thickness of the soil H naught. So initially we directly don't know what is the change in void ratio, but we know the coefficient of consolidation. Then substitute the relation here. Then we can say delta H, or primary settlement. That can be written as, substitute this value here directly. Then I can say AV into delta sigma bar divided by 1 plus E naught into initial thickness. So this is what we have to apply when we know the coefficient of consolidation. Similarly, like that, we are having different properties, like if we know the coefficient of compression index, then how do we have to find out the settlement? Similarly, if we know the compressibility, coefficient of compressibility, then again we have to know how to find out the settlement, right? So similarly, let us see one more important equation, that is, in the third case, let us say if you know the coefficient of consolidation, sorry, coefficient of compression index, then how can we find out the settlement? That is nothing but a primary settlement, or we can also call it as a consolidation settlement. That will be equal to H naught into Cc divided by 1 plus E naught into log 10 of sigma to effective stress divided by effective stress before the application of the loading. So this is what the most important relation, and by using this only, most of the questions are coming in the gate exam. So you know already, let us represent with the exam. Suppose let us say that, so we are having some clayey soil, and let us assume that the clayey soil is having a initial thickness of H naught. Okay, let us say H naught is nothing but a initial thickness of the soil, and Cc is nothing but a coefficient of compression index. Then how can we find out that value? So this value can be find out by using the, if you know the liquid limit of the present soil, that is nothing but a 0.007 into WL minus 10, or 0.09 into WL minus 10, right? So this is another question of compression index. Then if you know the liquid limit, then we can find out the Cc. Then E naught is nothing but a void ratio in the initial condition. So here we have to know the two things. What is nothing but a sigma 1 bar, and also what is nothing but a sigma 2 bar. So here sigma 1 bar and sigma 2 bar nothing but effective stresses where I have to take the effective stress. So wherever you want to find out the settlement, that means here if I want to find out the settlement that is happening in the clay soil, then always you have to take the effective stress at the center of the clayey layer. So always we have to take the stresses at the center of the clay layer, that means at this level. Then from here to here, h naught by 2. So while finding the settlement, always you have to take the, this is a very important point. So where you have to take, if you should not take here, and also you should not take at the bottom of the clay soil. Always you have to find out the stresses at the center of the clay soil. Okay. Now, so sigma, what is sigma 1 bar and what is sigma 2 bar? So before applicate, let us say that this is what the natural condition of the uh, soil condition. What do you think? Suppose at this level, do you think the effective stress is equal to 0? The answer is no. Why? Because above this layer, the soil is also present. So because of the soil present above the center of the clay layer, then sigma 1 is nothing but a, because of the soil, whatever the stress that will acting at the center, then that we are representing with the sigma 1. If you are constructing foundation, or if you are keeping some any external loading on the natural deposit, then let's see if I'm applying some external pressure. So because of this, what is the stress presenting at the center of the clay layer, then that we will presenting with the sigma 2 bar. So before the application of the extender, suppose if I talk about with respect to the foundation, that means before the construction of the foundation, after the construction of the foundation. So before the construction of the foundation, at the center of the level, because of the soil presenting above that, what about the effective stress present at that point? After the construction of the foundation, because of that, or including the soil presenting above the layer, whatever the stress presenting at the center of the clay layer. So those are what nothing but a sigma 1 bar and sigma 2 bar. So depending upon the conditions given, then so by substituting in this relation, we have to find out what is the consolidation settlement. Okay. Now let us start doing some example based on this relation. Okay. And let us assume that there is a saturated soil. There is a saturated soil. For the saturated soil, let us say that compression index is given as a 0.25. Okay. And the void ratio, initially they are given that the void ratio is nothing but a 0.9. And they have given that permeability of the soil we are representing with K, that is given as 3.5 into 10 to the power of minus 7 mm per second. And initially, initially the soil is at a stress. So in the initial condition, we are representing with sigma 1 bar. Let us assume that initially the soil is at a pressure of 12 kilonewton per meter square. So let us assume that in the first case, if the stress presenting in the soil, if the stress is increased to, if the stress is increased to 21.6 kilonewton per meter square. So initially, what is the stress, effective stress at the soil sample? 12 kilonewton per meter square. Suppose if we are increasing that to 21.6, then we have to find out, so what is the change in void ratio, and also we have to find out what is the settlement happening in the soil. So here we know the initial like we know the initial void ratio. Did they given any thickness of the soil? No, right? So let us say the soil sample thickness is given as the 6 meter. Okay. Now let us say first, how can we find out the change in void ratio. So how can you find out? Initial void ratio is given, initial thickness is given. So how can you find out the change in void ratio? So sigma 1, Prashant, the sigma 1 is given in the question. Sigma 1 is equal to 12 kilonewton per meter square. So again, that will explain you. Let us say, that there is a soil deposit, and let us say it is a composite soil deposit. Let us say here we are having some gravel, and let us say here we are having some clay material. Okay, now let us say I want to construct some structure on the soil deposit. Okay, so if it is a gravel, then okay, long-term displacements cannot happen. But if it is a clayey soil, that too, if it is a completely saturated, then because of the long-term loading, there might be a possibility that water may expel from the clay, and because of that, the settlements can occur. If it is very long-term, those will be very large in magnitude. So if the settlement is very large, then the settlement, if it exceeds the limit, then automatically we can call it as a failure. So before the construction of the foundation, so sigma 1 is nothing but a, you have to consider. Again, the next question is why I have to take the effective stress at the center point only. Why not I consider the throughout the clay sample? So that is what the question will arise. On an average, if you can consider the effective stress at the center of the clay layer, then it is found that whatever the values are coming, those are the acceptable. So that's why while finding the settlements, always we will take the effective stresses at the center of the clay layer. So in the natural condition itself, so because of this soil presenting here, so because of this gravel and because of this in the sulfate of the clay layer itself, there might be some stress that is acting on the soil. So because of the soil itself that is presenting above the layer, so that we will calling it as a sigma 1 bar. So because of the soil weight itself, so whatever the stress that is presenting, so that we are calling it as a sigma 1. Suppose if I have constructed a footing, or if I constructed some footing here, or if I constructed some structure, so definitely there will be some load that will be resisted by the soil. So because of the load that is acting on the soil through foundation, whatever the stress present at the center of the clay layer, that we will call it as a sigma 2 bar. Okay, now let us go to the previous one. So they are given increased in stress, and they have given the initial stress, and they are given initial thickness, compression index, and we have to find out the change in void ratio. So is there any relationship between the void ratio, compression index, and the increase in the stress? So if you recall the relationship, then we can say compression index, that will be equal to change in void ratio divided by log. So always remember while by adding the formulas itself, so if I am simply representing log, that is representing log with respect to 10. Suppose if I say ln of something, that means I am representing log with respect to e. Not only here, whatever the subject you are studying for the GATE exam, so while studying in obvious, we don't get any doubt, because as we are studying, native thinking may not develop in our mind. But while in the examination hall, the important, even though you remember it correct, but still you may get doubt that whether it is log with respect to E, or whether it is log with respect to 10. So in such cases, you have to think that if I write with respect to ln, or if I by having a formula with respect to ln, means that is log with respect to e. If I'm writing log, means that is simply is nothing but a log with respect to 10. So log of sigma 2 bar divided by sigma 1 bar. That's it. Substitute in the relation. Cc is given as 0.25. That will be equal to change in void ratio only we have to find out, divided by log of, that means log 10 of the stress, effective stress has increased to 21.6. That means in the final condition, what is the stress present in the soil? That is nothing but a 21.6 divided by initially what is the stress? That is nothing but 12. Then if you are solving this, then the change in void ratio, you will obtain it to be point change in void ratio you will obtain to be 0.0625. So this is also a direct formula based on the equation, but the important thing is how we will find out the settlement. So again, just recall the equation with respect to the compression index. If we recall it, then H naught into Cc divided by 1 plus E naught into log 10 of sigma 2 bar divided by sigma 1 bar. So that will be equal to initial thickness is given as a 6 meters. So let us convert into mm. So 6 meters is nothing but a 6,000, and compression index is given as a 0.25, and initial thickness, initial wide ratio is given. So the initial wide ratio is given as nothing but a 0.9. So directly substituted 1 plus 0.9 into log 10. So what is the final stress acting in the soil, or the soil effective stress is increased to the magnitude of 21.6 divided by initially what is the stress given, that is nothing but a 12. Then if you are solving this, then we will obtain the settlement happening in the soil in the form of mm. Why? Because as you have considered the thickness in the mm, then we will get the settlement value also in the mm. Okay. Now let us see some of the example based on the foundation. Okay. Let us say that there is a natural soil deposit and there is a water table present at the top of the soil, and let us assume that from here to here the soil is having a thickness of 9 meters, and from here to here the soil is having a thickness of 3 meter, and this is gravel soil, and below we are having the clay soil. And the gravel soil, let us say that gravel soil is having the saturated unit weight, that is given as 1.89 ton per meter cube, and for the clay soil the saturated unit weight is given as 1.79 ton per meter cube. And here let us say that the foundation is constructed like this, and the foundation is constructed up to a depth of 1.5 meter. Then if this is the case, then we have to find out what is the settlement happening in the soils, right? So let us say that liquid limit of the clay soil is given as the 54. Okay. If liquid limit is given, then based on that we can find out the compression index. So what is the equation for the compression index? So for the compression index the equation is 0.009 into wl minus 10. So if you remember this, there is some relation that is related to wl minus something. If you recall it, 0.73 into wl minus 20. So if you recall the equation of the a line, then that is also similar to this wl minus 20 there. Here it is wl minus 10. So wherever there is a similar equations, if there are coming, then we have to recollect here. Why? Because if you are recollecting here, then in our mind that will process, okay, the formula here is wl minus 10 and there wl minus 20. But if you didn't recall it, or if you don't observe the difference between these two, then in the examination hall again we may get confused. So wherever there is a similarity, at that point we have to stop and we have to think once and we have to recollect it. So if we do that, we may not commit the mistake in the examination hall. Okay. Now, so if liquid limit is given, then find out what is the compression index. That is nothing but a 0.09 into liquid limit is given as 54 minus 10. Then if we are solving this, let us say the compression index is obtained to be 0.396, let us say. And imagine that the initial void ratio is also given, that is nothing but a 1.08. So if we know the compression index, then how can we find out the settlement? So if we recall the equation, the settlement happening in the soil, that will be equal to H naught is nothing but initial thickness into compression index divided by 1 plus E naught into log 10 of sigma 2 bar divided by sigma 1 bar. So what is sigma 1 bar and sigma 2 bar, as we have already discussed. So let us solve this here. So H naught is directly given. What is the H naught? H naught is nothing but the thickness of the clay sample. So if you're taking clay sample, what is the thickness? It is given as 3 meter. So here I will consider H naught as it is 3 meter. I will represent it as in terms of the mm. So 3000 mm. Compression index already we have found out. How much we have obtained? We have obtained it to be 0.396. And initial void ratio is also given how much? That is nothing but a 1.08. So only the thing is, in this question we don't know directly, they have not given what is the effective stress before the construction of the foundation, and after the construction of the foundation what is the effective stress. So in this question only the thing is we have to concentrate on the effective stress. How to we have to find it? So let us say before the construction of the foundation, what is the effective stress? Where we have to take the effective stress, if you recall it, we have to find out at the center of the clay layer. So there are some cases where we cannot take exactly at the center. We will discuss them. So let us say that we have to find out the stresses at the center of the clay layer. So from here to here. So what about the total thickness is how much? 3 meter. So from here to here it will be 3 by 2. That will be nothing but 1.5 meter. Isn't it? Now, so let us imagine that if this foundation is not, we have not constructed any foundation, any structure, then what about this effective stress that is presenting here? Right? So sigma 1 bar. So that is because of the gravel, because of the weight of the gravel, and also because of the weight of the clay layer up to half of the thickness. So as it is completely saturated, then we have to take the effective stress. Effective stress means gamma saturation minus gamma W. So what is the effective stress because of the gravel? So whatever the thickness, 9 meters given, 9 into, what is the gamma saturation? 1.89. Whatever the gamma W in terms of the tons per meter cube, minus 1, plus we have to consider up to half of the magnitude. That means 3 by t is nothing but a 1.5. Up to 1.5 meter thickness of the clay layer, what is the effective stress? That is 1.5 multiplied by whatever the saturation weight, 1.79, minus gamma w. Gamma w is nothing but, let us consider it as 1. So this is what nothing but a effective stress that is acting at the center of the clay layer before the application of the, before the construction of the foundation. So if we are solving this, then we will obtain a magnitude of around 9.915 tons per meter square. Now we have obtained the sigma 1. The point is how we have to find out the sigma 2 bar. Okay. Now, so because of this foundation, what we know? We know what is the load that is acting on the foundation. So what is the load that is acting on the foundation? Sorry, how much did you mention anything? So let us say the load acting on the foundation, let us say Q, that will be equal to 900 tons. So because of this construction, how much stress is increased? That means the soil is already there. Are we removing the soil? No. But what we're doing, we are constructing the foundation. Because of the construction, how much stress has increased in the, at the center of the clay layer. So how can you find out the sigma 2 bar? This I can find out by using the relation that is nothing but a sigma 1 bar. plus delta sigma bar. That means the soil itself is there already. Because of the soil, we already know what is the stress at the center. But because of the construction of the foundation, how much stress is increased. So let us say if let us say initially 10 tons per meter square is acting at the soil. Because of the construction, if 20 tons per meter square is acting, then what is the total magnitude? We can say it is a 10 plus 20, that is equal to 30, isn't it? So wherever you are constructing something, because of that, what is the increased in magnitude? That we have to add it to the initial value. So what is the final value that I can represent as sigma 1 plus sigma 1 bar plus sigma delta sigma bar increase in value. So initial we have already find out. Then how can I find out the delta sigma bar? What they have given is, are we constructing the foundation directly at the center of the clay layer? No, right? But then how can you take the stress? Can we directly divide it by 900 divided by cross section? Can we directly do that? No, isn't it? Then how can you find out? So for that we have to follow the trapezoidal theory. That is, again I'm drawing here. So let us say that we have constructed a foundation like this, and let us assume that it is a square foundation. Okay, and let us assume that it is having a dimensions of 3.6 meter by 3.6 meter. Okay, yeah. Now, so as the load is applied on the foundation, how it will? Obviously, because of the construction, the load will be distributed through the soil. It will not always be distributed like a uniform in nature. So if we don't know how the stress is distribution, then we have to imagine it like a trapezoidal stress variation. That means imagine that the stress variation is acting like this. That means at this level, what will be the change in stress, change in effective stress because of the construction of the foundation. So if there nothing given, then we have to consider the variation of 1 is to 2. So if you are considering that variation, then if you are considering a trapezoidal variation, then it is observed that the change in effective stress that can be represented as by using the Q divided by B plus Z into L plus Z. So Z is nothing but a uh, total depth of the soil from bottom of the foundation to the wherever you are finding the stress. That means from here to here. What about the thickness? In the given question, we have seen it as a 1.5. Z is nothing but a from the bottom of the foundation. That means from here and from to wherever you are finding the stress. So from here to here, we will call it as a Z. Do we directly know? We have to find out. So from here to here, we know that the total amount is 9 meters. From here to here, what about the thickness? 1.5. So then what about this? Total 9 plus 1.5. So z equal to 9 plus 1.5. After the second, we have to neglect minus 1.5. So in this case, the z is coming to be 9 meters. So as it is a square foundation, then here I can say it as an increase in effective stress that will be equal to Q divided by, simply I can say it as a L plus Z whole square. So delta sigma bar that will be equal to, what is the total load given? 900 tons divided by, what about the dimension of the foundation? 3.6 meter plus Z value were obtained to be 9 whole square. So if we are solving this, then we will get this 5.66 tons per meter square. That's it. Substitute in the equation. So what about S value? S settlement. S is nothing but a initial thickness. So what is initial thickness? 3 meters. So if I take into meter, 3000 into, what about the compression index value? That is obtained to be 0.396 divided by 1 plus, what is the initial void ratio is given as that is nothing but given 1.08 into log 10 of sigma 2 bar. Sigma 2 bar, how we are expressing? We are expressing in terms of sigma 1 bar plus delta sigma bar. So sigma 1 bar is obtained to be around 9.9 plus, because of the construction of the foundation, how much it is increased? It is increased to be 5.6 divided by initial value is how much? 9.9. Then if you are solving this, then we can obtain the magnitude of the settlement. So here the point is, in the present problem, if we know the liquid limit equation, then we can find out the compression index, and initial thickness is given and initial void ratio is given. So because of the natural deposit of the soil and because of the construction of the foundation, then we should know how to calculate the effective stress at the center of the clay layer. Then only we can obtain the settlement value. Okay. Suppose here let me erase one doubt. That is, with a span of no time, can we construct a structure over there? Isn't it? Initially, like within 1 day or within 2 day, can we construct building and can we stay there? No, isn't it? Obviously, it will take some time. So, like it may take, if you are very hurry, then you may construct less than 1 year. Or if your construction is very late, then you may construct, you may take up to 2 to 3 years. That means whatever the construction we are doing, that means immediately that is not happening. Then for construction itself, that is taking some time. Then how much time we have to take then? So that is also one point. That means, let us say that, let us assume that, I am assuming that in 2020, let us say if I am taking some natural deposit here, okay, and I want to construct some foundation structure here. So I want to start a construction from 2020, and my name is that I have want to finish it by 2024. Let us see. Okay. So how much time I'm taking for the construction, for the complete construction, or for the complete action of the load acting on the clay layer or soil deposit? For I'm taking 4 years. In the 4 years of the span, then that means the load itself that is directly acting from 2020 onwards, or it is acting from 2024, or it is acting from 2020 to 2024. So whatever the load that will act, that will gradually increase. So after the construction is completed, then whatever the load that is acting there, that will remains constant. That means in the construction period of any structure, then the complete load that will not act it. So that may increase. So at the initial level, the load will not act at all. So after the construction is increasing gradually and occupancy is happening, then the load will increase, and after the complete construction, the complete load will act on the foundation. So wherever there is a time span for the construction, then for the calculation purpose, we have to take the reference as the center of the construction period. That means what is the center point for construction? That means 2022. So for finding the settlement analysis, we have to take the reference year as 2022. We should not take 2020. Why? Because at 2020 the construction is not at all happen. Similarly, you should not take 2024. Why? Because before 2024 also some load is acting on the soil deposit. So you should not take either 2020 or you should not take 2024. So further, that means, suppose if I want to find out because of the construction of the foundation, if I want to look into or if I want to find out at 2050, if I want to check it, what are the settlement happening in the soil? So how much time span I have to consider? Do I have to take 2050 minus 2020? No. 2050 minus 2024? No. So if you want to find out the, or if you want to estimate the settlement for the 2050 year, then we have to take the time span. That is nothing but a 2050 minus, what is the center of the point? 2022. That means if you want to find out the settlement in the year of 2050, then you have to take the time span of 28 years. You should not take 30, you should not take 26. Okay, so this is what for finding the settlement if the time span is given. Okay, and also let us discuss that. Imagine, mm, let's say in the first scenario, so let me write it in a smaller manner. And this is in the second scenario, and this is what in the third scenario. In the third case, let us say that I am applying the external stress. Let us say it is having a magnitude of q. In the first case, let us say that so let us say that the soil is completely under dry condition. Okay, let us say the dry weight is gamma d, and from here to here we are having some clayey layer. Let us say that at the center of the layer, in the first condition, let us say you are having some effective stress is equal to 20 kilonewton per meter square. Let us assume that because of the some condition, the water table level has risen to here. Or even if you want to specific, let us say that the water table is raised here. If your water table is raised, obviously that the effective stress will decrease. So because of the rise in the water table in the second condition, so what will be your effective stress? Let us say that you applied it is 10 kilonewton per meter square. Let us assume that. And after the, so again the water table is here and you are applying some external pressure on the soil deposit. So because of the external soil deposit, so what about here? Let us say in the third condition, the stress is obtained to be 100 kilonewton per meter square. So if we observe here, initially it is at a level of 20, but after that it is again to 10. After reaching 10, we are applying the magnitude of 100. So what we can observe, we are applying the, or we are increasing from 10 kilonewton per meter square to 100 kilonewton per meter square. But what is the point here? So in the previous year, the soil is already consolidated more with how much amount? 20 kilonewton per meter square. In this case, how can we find out the settlement analysis? So that means if any soil is pre-consolidated soil, then we have to use the recompression index. So what are the level here? So what is the least value? 10. What is the highest value? 100. In between, what is the change in value? That is nothing but a 20. That means from 10 to 20, the soil is already pre-consolidated. So wherever there is a pre-consolidation, there we have to use the recompression index. So if pre-consolidation is not there, then we have to simply use the compression index. That means, so wherever there is a pre-consolidation happen, there we have to use the recompression index and then you have to find out the settlement. That means from the 10 to 20, what about the settlement? And from 20 to 100, what about the settlement? From 10 to 20, already the soil is pre-consolidated. Here we have to use the recompression. That's it. Again, reframe the equation. Nothing but a initial thickness as it is prior consolidated CR divided by 1 plus initial thickness into log 10 multiplies the, what is the final one? 20 divided by 10 plus similarly H naught. From 20 to 100 we have to take the compression index divided by 1 plus which void ratio we have to take. Here we are considering from 20 to 100. So let us say that corresponding to the 20, the void ratio is even. So here we have to take 1 plus E1 into log 10 of 100 divided by 20. So that means wherever there is a pre-consolidation is already happened in the soil. So wherever there is a pre-consolidation, there we have to consider the recompression index and then the remaining part we can take the original curve. that is nothing but a virgin core, that is nothing but a compression index. So all these things in details we have explained in the videos. So buy the course and start, be safe and start listen the videos and practice it, do well in the exam. Hope it is understood well. Thank you so much.